Hi, today we're going to see the topic, the exercise 1.2 of the real number chapter. Let's start with the topic. Here, we need to prove that root 5 as an irrational number. So to prove it, we need to take that as the rational number. Let's start with that. Now solution. Let us assume the root 5 as the rational number in order to prove that as an irrational one. Let us assume root 5 as rational number. As we know that what is exactly rational number, that is numerator by denominator form, that is p by q form, correct? So whenever there is a rational number word is mentioned, so you have to write the given number in the p by q form or n by d, that is numerator by denominator form. So let's take, there exists two integers, that is p and q, they are co-primes. Co-primes. So what do you mean by co-primes exactly? The co-primes means their LCM is 1. That means they are commonly divisible by the answer what you get after when you divide p by q is 1. So that is what the co-prime meaning. So we will assume root 5 is equals to a by b or p by q. Anything you can take. You can take here a by b only. So any alphabets you can take. As it's a variable, you can take any number. So here I'm going to do the next step as cross multiplication, that it will become b into root 5 is equals to a. Now in order to cancel this root, so what we will do is square root on both sides. So square root on both sides. Here it become b square. Here root 5 whole square is equals to a square. Now root 5 whole square is square root and square cancels. So b square is equals to 5a square. Now I'll send the number here. So b square is equal to a square by 5. This is what the equation. Now consider this as the equation 1. From here I can say that 5 divides a square, correct? 5 divides a square, as well as 5 divides a. Now 5 divides a square, you are getting b square. When 5 divides a, you are getting some other integer, correct? So a by 5 is equals to c. Again you cross multiply it, what you will get? A is equals to 5c. What is c? C is again integer. C is again integer. Now consider this as equation 2. Now substitute 2 in 1. Equation 2 in equation 1. Where you have to substitute? In the place of a, you have to substitute this 5c. That is b square is equals to 5c whole square. That is in the place of a. Divided by 5. So this becomes b square is equal to 25c square divided by 5. 5 get cancels. So here you will get b square is equals to 5c square. Correct? So if you see equation 1 is equals to a square is equals to 5b square or b square 5. You can write any way as of you want. The equation 2 is b square is equals to 5c square. So from equation 1 as well as from equation 2, if you notice that they have the factor 5. Correct? They have the factor 5. That means a and b is having common factor 5 other than 1. But it should not have 5, correct? It should have 1 if it is a co-prime, correct? Then therefore our assumption is wrong. That is what we need to prove that. Therefore our assumption is Wrong. Root 5 is irrational, irrational number. Now, as of 5, we saw that root 5 as how we have proved step by step that it is irrational. Now we need to prove for root 3. How you will prove? Wherever the root 5 is there, if you write 3, you will prove that root 3 is an irrational. Just will change it. The same theory, the same procedure, everything is same. Just change the number. Here 3 is there. Here 3 is there. Here 3 is there. So this will become 3. This will become 3. Here 5 it divides 3. So here it is 3. Now here also it is 3. Becomes 9. Becomes 3. 3. Then here 3. So what you got finally? See here. Let us assume that root 3 as rational number. When it is a rational number, there should exist a by b form. It should be represented in a by b form. So there exist two integers, that is a and b. They are co-primes. So here root 3 is equals to a by b. As we assumed as rational number, we have written like this. The next, if you cross multiply it, b into root 3 is equals to a. Now, in order to remove anything, if it is in square root form, you cannot solve that. So, in order to solve it, we have to remove the square root. So, that is why we do here square root on both sides in order to remove the square root. When it's not square root, it is square on both sides. So, when you do square on both sides, it becomes b square. Root 3 whole square is equal to a square. Now square and square root get cancels. You will get b square 3 is equal to a square. From here we can write that 3 divides a square. Therefore 3 divides a. Okay. When 3 divides a, there must be some other integer you will get. That is we assume it as c. Now again you cross multiply. You will get a is equal to 3c. That is we consider as the equation number 2. Now what we do as previous problem, how we have substituted the equation 2 in equation 1, like that we are going to substitute. As we get substitution, we get b square is equal to 3c square. That is b square is equal to 9c square. Okay, here in this equation as we are substituting b square 3 is equal to a square. A square is now 3c square. Now we will send 3 this side. It become 9c square by 3. 3 ones are and 3 threes are. So we will get now b square is equal to 3c. When b square is equal to 3c, here and here, now a is having a factor 3 and b is having a factor 3. Now both a and b are having a common factor 3 other than 1. If it is a co-prime, they should have only 1, right? But here they have 3. Therefore our assumption is wrong. Therefore root 5 is an irrational number. Now we will see. Next question is, we need to prove that 3 plus 2 root 5 is an irrational number. Now before that we were solving a single term, that is monomial. That is one term we were proving it as irrational number. But here we have two terms. That means you may have here in middle plus or minus. So that time we should consider that as the binomial. Now two terms we have. The same procedures we follow, only few steps it changes. Just we will solve this. Assume 3 plus 2 root 5 as rational number. There exists two integers. There exist two integers, a and b. As we know already that a and b are co-primes. So let's rewrite 3 plus 2 root 5 is equals to a by b. Now what is we are going to do here is, we will keep the root part which we need to solve it, remaining all the other numbers we are going to send that side, that is right hand side. So 2 first we will send. So it will become, as it is going from left to right, This will become minus 3. Now again 2, one more 2 is there. As I send 3 here, this becomes minus 3, then I'll send 2. So root 5 is equals to a by b minus 3. As it is 2 into 5, when the 2 goes this side, it will become what? Denominator. It will not be like minus 2. It is denominator. Since it's a multiplication, it's considered as single term. So root 5 is equals to multiply this 2 inside. A by 2b minus 3 by 2. So this is what you can say. Consider this as the equation 1. Now, root 5 is has a by 2b minus 3 by 2. If you see the number itself, you can say that this is a rational number, correct? A by 2b and 3 by 2, as it is numerator and denominator form, is a rational number. Therefore, root 5 is also rational number. How? Because this is equal to this we got. But this is wrong. What is root 5? We know that root 5 is irrational number. But we try to prove it by taking in the reverse order, as that is as the rational number. So therefore, but our assumption is wrong. Therefore, root 5 is irrational number. 3 plus 2 root 5 is irrational number. See, when you're adding some number to the irrational number or subtracting some number from the irrational number, the answer is always irrational number. It is not the integer. Thank you.